Good morning. Sorry for
Hello.
joining last moment.
Even I just said that we'll probably wait till about 5 minutes after to actually start as people trickle in. And I'm suggesting now is a good time for folks to test their mic and cameras.
Great.
Daphne, we can see you just fine, but I haven't heard anything from you yet. I can't tell if you're actually speaking or not.
I have not spoken yet. Can you hear me now?
Yes, we can hear you fine.
Excellent.
Thanks.
I had a little bit of fear that this wasn't going to work. I tried the Echo server for RTC Web online, no luck. So I'm pleased this is running so well.
Sounds like the Echo server needs to be debugged.
Yes.
Debugging the debuggers.
Yes.
For folks who just joined, we'll probably get started in about 5 minutes. Now's a good time to test your microphone and camera if you want to do that.
Hi, yes, it is me. I hope it's working. The phone booth in here has a very unfortunately positioned light source, so it always looks dreadful. But I think is my
your audio works great, Andrew. Much better than the last time that we tried this.
I'm
you
really glad.
look like a religious icon, you know. It's okay.
I'm very fuzzy at the moment. Yeah.
Remind me the etiquette here: muted and camera off if you're not talking. Is that how this?
Yeah, we'll go over
works?
that in a minute for the chair
Okay.
slides, but the general etiquette is muted and camera off unless you're chairing or presenting or speaking, like when you have a question. But
right, makes sense.
Now's
Okay.
a good time to be able to see each other briefly, and then we'll all go
All
back
right.
to camera
Looks
off.
like my shit works. I will go back to lurking.
Good to meet you finally, Daphne, by the way. we've spoken a lot on email, but otherwise, not much. Thanks very much.
So, DKG, have you rounded up a note taker already, or are we still to do that?
I have not.
Okay. So,
that's a good call, Stephen.
Does anybody feel that the love for keeping a few notes of things that are agreed and actions? We don't need narrative notes because the recording will be there.
Right, we have the narrative, and there will be slides, and nothing that's in the slides or in the narrative needs to be recorded. Just concrete decisions or unusual points that were surprising that were raised. And there is a note-taking button at the top middle of your screen. Looks like a pencil on a square piece of paper. Anyone who's a note-taker can pick that up, and we just need someone to volunteer. If you volunteer, you will get a selection of OpenPGP stickers with our beautiful new badge.
If nobody volunteers, I can try to take notes.
Thank you, Daniel. I appreciate that.
No worries.
Thanks, Daniel.
And if somebody wants to help Daniel out, it's a synchronous, simultaneous note-taking tool. So, you can, while Daniel's speaking, somebody else can fill in whatever points he's making, if that would, if you want to help out. So we are at 5 minutes past the hour. I think we should get started. This is the OpenPGP interim meeting in September 2024. Welcome. Looks like we have about 13 people, give or take, present, which is nice. Stephen Farrell and I are your co-chairs. So this is the note well. If you're participating in the IETF for the first time, I don't see anybody novel to the IEF in the attendee list, but you should know this note well from your previous times. If you haven't, I recommend you go back and read this stuff. For an all remote meeting, we do request that people take your mic off and your audio off unless you are chairing, presenting during a session, or speaking from the queue. If you've got a headset, it would be great to use your headset. If you want to speak, add yourself to the queue. You can see the queue button being the little hand down at the bottom that says join queue. And there's a text chat running. We expect there's enough people who tend to operate on text. If you can follow the text chat simultaneously, that would be great. Another reminder about the code of conduct. We want to be good to each other. Feel free to attack ideas. We want to come out with the best thing possible, but we don't need to attack each other as people. And those of us who are native English speakers should probably slow down and limit the use of slang. So yeah, you should be aware of these things. On the agenda, as a brief recap of since the last time we met at the IETF 120, we now have a released RFC. So there'll be a couple of slides of simple recap that I'll do, and then Andrew Gallagher will lead the discussion of his and Daphne's replacement keys draft. And then if we have time permitting, we will handle any other business if folks want to raise it. So this is scheduled for an hour and a half. We don't need to take the full hour and a half. If we want to give time back to people, that's also okay. But from looking at Andrew's slides ahead of time, I suspect we will have several questions to grapple with. Sorry, does anybody want to bash this agenda, propose anything else that needs to come up in this particular meeting? Giving folks a chance. I'm not hearing anything, so we'll carry on. If you have things to come up, as usual, feel free to bring them up. Okay, so so the crypto refresh, which is what we were originally chartered to do, is complete. It's been released as RFC 9580. There was a tremendous amount of detailed nitpicking feedback towards the end from Ayanna and the RFC editor, which the editors, Paul, Nipe, Daniel, and Eustace all pitched in to handle. I've never seen anything quite that long, but it was great. If you are an implementer, please update the internal references in your implementations to point to the RFC and not to the crypto refresh. If you're writing other drafts that refer to the crypto refresh, I recommend you update those drafts and point them to RFC 9580 instead. One quick note about interoperability. This is a picture from the OpenPGP interoperability test suite, and you can see that we have a half dozen interoperating implementations using the updated key material from RFC 9580. Obviously, there's much more in RFC 9580 than just this key, but I thought this was an interesting chart to look at. Each of these things is a development branch of an existing OpenPGP implementation. And so the hope, I guess, is that those implementations will make a new release at some point, and we will consolidate at least a half dozen implementations that support OpenPGP version 6 keys. So hopefully we'll see some new releases soon, and we've got demonstration that things work. And now on to the main part of this conversation, unless folks have more comments on RFC 9580. All right, so Andrew, if you want to click on show slides, I can grant you that permission, or if you'd prefer, I can run the slides and you say next slide. Tell me what you prefer. Okay, so I see the request and I don't know how to grant it. Stephen, can you help? There we go.
Yeah, you have to click on him. He appears in the queue with the request, and you have to click on that queue thing.
Got it. Next time, I'll try to remember that. All right, I'm going to go off mic and off camera. And Andrew, the floor is yours.
Okay. Thanks very much, Daniel. Thanks everybody for coming. So the matter at hand at the moment is the replacement key mechanism draft. It is currently published in an IETF 00 format under draft IETF OpenPGP replacement key 00, which you should be able to find in all of the usual places. So this is a reworking and a refreshing of Daphne's original draft from way back, and it's great to see some neglected ideas coming back into OpenPGP, and I hope this will be the first of several. So the basic design of the replacement key mechanism, we've already gone over this before, but just to remind everybody, it is a signature subpacket for use in revocation signatures and self-signatures. The way that we have specified it currently is that it is preferred on a direct key self-signature. It consists of a version octet, a class octet, and then 0 or more targets. And these targets consist of the version and fingerprint of the target key, what I tend to call a version tagged fingerprint. It's the same format it's used on the wire in several other places in RFC 9580. And then following that, it asks for an imprint of the target key. Now, imprint is a kind of a newfangled word that I made up recently to try and describe what this was. It's essentially the same thing as a fingerprint over a key, except that instead of using the digest algorithm specified for that key's version, it uses the digest algorithm that is in use by the enclosing signature. This was inspired by the attested certification subpacket, which uses a similar construction where it contains references, and each of these references is calculated using a digest algorithm that matches the digest algorithm of the signature itself. This means that at all points we are relying on the same strength of cryptographic digest algorithm. The reason for that is that we are concerned that if we are referring to older keys and those keys have fingerprints with deprecated digest algorithms, that this would be less cryptographically sound than an equivalent subpacket, a sub key binding signature, which would always be made with, or would usually be made with, the most recent digest algorithm. So this packet can be used in two directions. The original design had it pointing forwards from the original key to the replacement key, but after discussions with several of the implementers, they wanted some way of forming a cryptographically strong binding between the original key and the replacement key. So we introduced the reverse subpacket, which is distinguished from the original by a flag bit. So altogether, this gives you a hint. If you see an original key, it gives you a hint for where to find the new key. If the new replacement key has a corresponding signature subpacket, then that performs an equivalence binding. And we can also, because the inverse subpacket can contain multiple original keys, we then use the order of those keys in the subpacket to determine a preferred ordering of equivalent keys for fallback purposes. So for example, if there is a replacement key that maybe has maybe say a post-quantum encryption subkey that isn't understood or supported for whatever reason, there is a way to fall back to a previous key that has maybe an encryption subkey that you do have or you do support. So there are a few outstanding questions as of today. So several of these have been brought up in the issue tracker on GitLab. So thanks, Justus, for your feedback, and I hope we're covering all of your points here. And there are a couple of other points that I'd like to raise myself. So in no particular order, Issue number 8 it concerns whether the subpacket version and the class octets are really necessary inside the subpacket bar format. We'll get to that in a second. Issue 15 is whether we really need to define the imprint fields and are the fingerprint fields sufficient. And then 14 is how do we specify that a correspondent should encrypt to both the replacement and the original key in the case of, say, for example, the key owner has multiple devices, some of which may support the replacement key and some of which may not. This, as we will see, is a larger question. And then, of course, there are a few questions around user experience. How do we present these to users? How do we encourage people to set this up? What order are users expected to do this in? Do they work on the new key, on the replacement key first, and then port that back to the original key? But I will get to that in due course, hopefully. So, question number 1 is the class octet necessary? Now, I believe that it is, but we'll go through the details here. So the class octet contains a series of bytes that we use as flags. This is a reasonably common construction in OpenPGP. It's used in several other subpacket definitions. We use these flags to signal the directionality. In other words, is this pointing towards the replacement or towards the original? They're also used to denote nullity, which is an explicit declaration that there is no replacement key. So you shouldn't bother going looking for one. The advantages of this method are that we only need to define one kind of subpacket. And as came out of the discussions with the implementers, we wanted a simple equivalence binding construction that did not involve potentially arbitrary length chains. And the way that we enforce that is by saying that there should be at most one replacement key subpacket in any self-signature. So you can either specify the forwards or you can specify the inverse relationship, but not both simultaneously. So we can't construct, arbitrary length chains. This, makes the logic and the implementation side considerably simpler to implement. And also, we may wish to use class octets for other things in the future. And there's one possible suggestion in a later slide. Daniel.
Can you talk a little bit about what you see as the difference between nullity and no such subpacket?
So no subpacket is the lack of a statement. Nullity is a specific statement that there is no replacement. So, for example, if you were doing, if you say you were revoking a key for the reason that this email address no longer exists, you could specifically put in a null, no replacement subpacket to, make an explicit statement about that. Whereas if you were revoking a key for some other reason, you might want to leave open the option in the future that you might go back and create a replacement key for it. We haven't been prescriptive about how this is used or how this should be used. I don't know, maybe Daphne could speak more to the original motivation of introducing the no replacement bit. But I think it is potentially useful, and so I'm minded to keep it in.
Yeah.
The
intent of the no replacement bit was literally just exactly what you said. We don't know. It was an intent to simplify the job of the implementer, who then does not have to go hunting for another key. If we say, hey, I'm revoking this one, saying nothing says, hey, this might show up in the future. Saying I explicitly say there's nothing here, stop looking, fail, error back to the user.
Yeah. Does that answer your question, Daniel?
Yeah, I think it does. I worry a little bit because, prediction is hard, especially about the future, as they say. And it's hard to know, putting a tombstone like that, it's hard to know when to really trust that that tombstone is, like, as a consumer, it's hard to, I can't see how I would know whether I should go ahead and rely on it, or whether maybe at some point the person does decide they want to come back to use OpenPGP or something.
Daphne?
Yeah, my thinking at the time, anyway, can't speak for today. My thinking at the time was that if somebody wanted to add a second, a newer signature replacing the original one, a later date, whether that's still feasible or not in the new draft, I would have to double check, was that, I'm setting this tombstone, but I do still have the ability to remove it. So it's a temporary stop looking.
Right. So that wouldn't work for a hard revocation, though, right? I mean, a revocation that says,
Right.
This is permanent, then that's including that in a hard revocation would basically mean, we're all done here somehow. But I guess I'm not sure entirely what the semantics are for that.
Well, as I understand it, a hard revocation means that you can't trust anything. So any signature made by this key, including the hard revocation itself, is untrustworthy. Because if, say, the key material has leaked, and it was hard revoked, the attacker could create a hard revocation with a different subpacket. So we have to ignore all of the subpackets in a hard revocation. We have to ignore creation times. We have to ignore everything. A hard revocation is a nuclear button. It only has one piece of information, and that is do not trust this ever under any circumstances. Okay. Sorry, Daphne, your hand is still up. Do you want to speak, or?
Sorry, no, my mistake.
No,
I'll put it down.
It's all right. I've done that loads of times myself. Okay, well, I'll move on to the second page of this, and then maybe we'll stop for a second, because I've broken these up into digestible chunks so that I hope we can discuss each of them separately without getting too tangled up in combinatorics. So the alternative to using the class octet is to define multiple subpacket types for each particular semantic. Now, aside from the issue of using up subpacket code points, which may or may not be an issue, but let's forget about that for the moment. It also means that we're duplicating specification, possibly duplicating bits of implementation. It gets a little bit messier when you have multiple subpackets that are all doing more or less a variation on the same thing. But also, and I think the killer argument here is that the simple argument of at most one of these subtypes of subpacket, no matter what the class octet says, then becomes, well, at most one of this list of however many different semantic alternatives. And if we introduce in the future perhaps a new semantic, that will mean a new subpacket. That'll mean going back and rewriting this at most one of algorithm to include the ID of the new subpacket that defines the slightly altered semantic. So having the class octet for these variations in semantics means that we can keep this there is at most one rule intact and reliable on that, and not have to worry about backfilling changes to that in the future. So I am personally very keen on keeping this class octet, but if anybody wants to make a counter argument, please feel free. Now's your time.
We can also run a poll here, but Bart, go ahead.
So I don't know when necessarily the right way to do this, but I from a design perspective, I dislike this inverse thing. I think it's ugly, and people are going to fuck it up. Is my general take. The other problem I have, I'm not entirely convinced of the need for the null, to be honest. But the other issue I have, I remember at the OpenPGP summit we discussed that the backward looking version of this, like for on the replacement key, may have a list such that you could say, instead of having, and I know the semantics sort of currently enforce a linear kind of history, right? But there's still kind of a problem where I have this old key and this old key and this old key, and if I do a bunch of this stuff, only two keys can have this key equivalent relationship, right? And the other ones, right? I mean, if I'm reading the spec correctly, like only two of them can have this full key equivalency. I mean, did I read the wrong version somehow?
No, that's not the intent at the moment. So let me think. Maybe an older version has it where the inverse subpacket can only have one target, but the current version, that's draft IETF 00, definitely has that the inverse direction subpacket has a list of n originals. So, and this was motivated by the discussion that you mentioned, where we have a number of original keys that all have a forward subpacket pointing to the canonical replacement. And then the canonical replacement has the inverse direction subpacket, which contains a list of all the originals in the preferred fallback order.
Mm-hmm.
And
I think I see the diagram now. It's target key version 1, target key version fingerprint imprint 2. So I see that it can be a list. I think the text, I think I was reading the text and it didn't, maybe the
right. Okay. Yeah.
Not there yet. Okay.
Sure. If that needs improved, then absolutely. Yeah.
Okay. That might just have been my, quick reading comprehension fail, but I noticed that. I was like, oh, I thought we changed that. But yeah. Okay.
We did. Yeah.
The one to many is fine, because I think, as we discussed, I think chaining is bad, but I wouldn't be opposed to have this be two different types, because I think it, rather than an inverse bit, because I think it's just less error prone, and I could be wrong, but I don't think the code point, wasting code points is a very strong argument for not doing it. That's my 2 cents.
Okay, thank you. Anybody else want to chip in?
So if y'all are okay with this, I would be up for running a brief poll. Stephen, you want to?
Yeah, just I'm not sure if it's the right place to ask this, but just the terminology of something and inverse is perhaps easily confusable, and the something is not clear. Just from looking at the document, I mean, I guess I know what it's supposed to mean, but I'm wondering if we could think about that terminology at some point and decide whether to, if there's some clearer names that we could have on these things, that doesn't impact on how you structure them in the protocol, though.
Yeah, inverse directionality is a bit of a mouthful, and inverse, yeah, I can see how that could maybe be interpreted as something else. So, like, I'm open to suggestions for better terminology. Absolutely.
I think if we focus on sort of the equivalency part, that could make it clearer. Like you could say, trust equivalent key, and then it kind of works in both directions, right? Like if both of them have it, then both of them are, let's say, trust equivalent to each other, and then you have a flag saying which one of them is the preferred one, if that makes sense. Does it make sense?
Okay.
Or no?
I'm not sure how this. So, how would you manage the multiple, the many to one relationship in that scenario?
I guess you would have to say that you can only indicate one as being the preferred one. So if you say like, here's a trust equivalent key and that one is the preferred one, then you can have only one. Whereas if you say, here's a bunch of trust equivalent keys, but I'm the preferred one,
Mhm.
then you can have multiple, right?
Yeah, yeah.
Something like that. I think would make sense. And I am kind of partial to the argument that saying that you can only have one of this sub packet is kind of simpler than you can only have this one or this one, but not both, right?
Mhm. Yeah.
That is a good point. But there, of course, that's a trade-off with you have this type can have multiple target keys, and this type you only have one target key. So you get your complexity somewhere, I suppose. But sure.
Yeah, I think the complexity does come in. It's inevitable that the complexity will come in at some point. I think putting the complexity inside the sub packet rather than outside it, if you follow me, keeps it slightly more contained. If we are defining multiple sub packets, then I'm thinking of that as the complexity is outside the sub packet. Whereas if we have a sub packet where there are different internal formats of that, then the complexity is inside the sub packet.
Okay, so I'm going to run a poll just to get a sense of the room here. And the poll is going to say, should we drop the class octet? So you should say yes if you think we don't need the class octet, and you should say no if you think some variant or some form of the class octet is necessary. Does that make sense to folks? Anyone want to wordsmith the text? Okay, should we drop the class octet? Okay, so that's a pretty clear sense of the room here. Stephen?
So just for the recording, that was a 0 yes, 8 no, 1 no opinion.
Okay. Thanks, everybody.
Carry
Daniel?
on. No, go ahead. Sorry, I misclicked.
That's okay. Okay, so the other question, which was mentioned in the same ticket, but which I've decided to split out for clarity, is whether there needs to be a version octet. So I suppose the argument in it for a version octet is it does allow for extensibility in the future. The argument against is that it's unclear whether there are version octets in other subpackets. The key block and literal data meta hash in LibrePGP do have a leading 0 octet, which could be a version octet or might be a class octet. It's unclear from the specification how they're intended to be used in the future. They are obviously there for some kind of future extensibility, but beyond that, it is not clear. If we have the class octet, also, we could merge the functionality of the subpacket version octet and the class octet, because there are plenty of bits left in the class octet that we can play with if we do want to define subtle new semantics in the future after we've had a while to play with this. So I know Daphne was quite keen to have the subpacket version octet in, so maybe I don't know what did you have a specific motivation for it, Daphne, or?
Honestly, my original intent for the version octet was just simply a way to deal with the oops messed up somewhere in the design situation. And it was like, oh, well, we discovered the such and such flaw in version 1. Okay, everyone go to version 2. Or, you stop supporting version 1, start supporting version 2. It just gave you that kind of flexibility. I mean, you can do the same thing with just defining a new subpacket altogether. You know, we don't even know that a new version would necessarily have the same on the wire format as the first one anyway. It was just sort of one. It was one more way of differentiating between multiple types of the overall subpacket. So, you know, it's not something that I'm super duper wedded to. It really was just, it was a get out of jail card that could be played.
Okay, so I suppose I'm not super duper wedded to it either personally, but I will of course defer to the room. Daniel.
Speaking as an implementer, not as a chair, I'm pretty scared of just having one more way to deal with things because of the complexity of OpenPGP generally. And the version octet to me seems like you now have to define a bunch of additional semantics about what do you do if you see a version that you don't understand. You know, could some new versions have different, could there be more than one packet in the new version? Like what are the invariants that are held for this subpacket type? And I think while it might give us get out of jail free, there are other ways to get out of jail free if this design is terrible, if it turns out that it doesn't work in practice, like the new subpackets. So I'm inclined to say don't introduce the extra complexity on the wire. We've had lots of problems with version negotiation in many other places, and I don't see the point of adding an extra.
Okay. Anybody else want to chip in? No, it appears not.
Would you like a poll on this one too?
I think we should just follow the same procedure for each. There's going to be like
okay. So this one's going
to
say,
these. So
yeah, should we drop the version octet? Seemed like a reasonable text. Anybody wants to wordsmith the poll text?
I think if we stick to a similar wordsmith construction for each one, it'll be less confusing for people. So,
yep.
Yeah. Okay, so we have 9 responders. That's like the same as we had last time. So that's 6 yes, 3 no opinion, and 0 no's. Nobody wants to keep it. Thanks everybody. I think that was pretty clear. Sorry, Daphne. Looks like we're removing the version octet.
No, that's fine.
Okay. Okay. Moving on quickly. Yeah. This is probably the bigger one. Excuse me. That we really need to nail down, and that's the imprint fields. So because we are effectively treating these 2 keys as aspects of the same object, the rule of thumb, kind of like the mental crutch that I used throughout all the discussions that we had with the implementers previously, was this should be the same thing as a subkey binding signature. So it should be of similar cryptographic strength. In particular circumstances, it has a similar semantics, not exactly the same, obviously. And then the thing that jumps out is that if we are relying on, for example, a v4 fingerprint, we're relying on SHA-1. SHA-1's deprecated. Now, an actual exploit does require a second pre-image attack, because we're not talking about a scenario where an attacker can forge 2 arbitrary documents with the same digest. These are, these keys are under your control, so an attacker would have to forge a key that is the same as one that you created, which requires a second pre-image attack, and then it would also require some kind of key overriding or key substitution attack to trick you into signing over the attacker's key rather than your own key. So, the attack itself is rather unfeasible. But as a matter of principle, and particularly since I hope this is going to be a generic mechanism, that we're not going to invent another one when we upgrade to V7 or whatever, there may come a point when, for example, SHA-2 is catastrophically broken and we all need to change, in short order to SHA-3, for example. It's possible it could happen. In which case we want to keep, we want to be able to upgrade all of our signatures to SHA-3. In that scenario, like, is the old key just completely, untrustworthy and shouldn't be used anyway? So Justus made a good argument that, if SHA-1 was completely broken with a second pre-image attack, well, then we wouldn't be asking people to fall back to it at all, would we? So I suppose we need to drill down through the actual plausible scenarios here. Now, the advantage of having the imprint is that it's a potentially, generic mechanism that can be used for anything. Like I mentioned before, this was inspired by the attested certification subpacket, which uses something similar for digest over signatures. It's also worth noting that OpenPGP has possibly implemented something similar in the latest version of the revocation key subpacket. It's unclear from the documentation, but certainly Werner has been thinking about it. Basically creating SHA-256 fingerprints in inverted quotes over v4 keys. I mean, that is something that is being thought about elsewhere. One of the disadvantages is, of course, that in many cases the imprint field and the fingerprint field are going to be the same. Particularly if it's a v6 key, it's SHA-256 in both cases. Are we just wasting bits on the wire doing it? And do we want to deduplicate if the two are the same? But then that makes the parser more complex. So I'd just like to throw this open to the floor, basically, to see what people think. Daniel.
Yeah, so for completeness, we have also done something similar in our implementation of key transparency at Proton, where we indeed also include SHA-256 fingerprints of v4 keys. Even though, as you've said, I don't think there's, I mean, the attack is not that plausible or likely to happen. But I think it's potentially reasonable as a, like, I like the concept in general of indeed having an imprint. I'm not super sure if it's necessary here, but I'm not opposed to it either.
Okay, thanks. Anybody else? DKG, I know you had several opinions about this before. Maybe you want to share them.
Sure. I mean, I just put it in the chat here, but like, I think the motivation here is not there is a dangerous attack. The motivation here is that it's nice to be able to tell the story that OpenPGP does not depend on SHA-1. And that is a simpler story that you can tell people who don't understand all the nuances and the trade-offs. And the more that we can tell that story robustly, to say we are not introducing new dependencies on SHA-1 in 2024, the easier it is to communicate outside of the OpenPGP world that, but that we're taking these, that we take these things seriously, and that we are, striving for modern cryptographic strength. As Daphne put in the chat, also, the fingerprint is a common handle for finding keys on the network, and the imprint, it says prove that we got the right one.
Yeah.
And I think that matches with the way that I was thinking about it.
Yeah, that's certainly the way that we were arguing internally about it, is that you can either have a stable identifier, or you can have an up-to-date solid proof. If you're a stable identifier, the perceived strength of that identifier will weaken over time inevitably. So you will want to upgrade the strength of your proof. So you will inevitably end up with some kind of divergence between your identifier, which will lag, and your proof, which will hopefully keep up to date. Eustace?
I don't find that argument convincing, because first, we are not adding a new dependency on SHA-1. We are saying put the key identifier here, which for v4 keys means using SHA-1. That's true. But then again, even if we go with imprints, we are still putting the SHA-1 fingerprint into the subpacket in order for people to find the key material. So I'm very confused by that argument.
Yeah. So I can try to deconfuse the argument a little bit. I mean, so some folks here probably are aware that I would be happy to see fingerprints themselves die. I actually think that they've never been fit for purpose for any of the things that we use them for. And if there was a way to locate a key by arbitrary imprint, we only have a limited number of digest algorithms in OpenPGP. And if the imprint was, a network lookup thing, I'd be happy to drop the fingerprint. I agree the fingerprint feels redundant, and it makes the packets longer. And we actually don't have any places on the wire where where we depend on the fingerprint. We have hints about issuer fingerprint on the wire, but we don't have. There's nothing that actually cryptographically depends on the fingerprint on the wire that I'm aware of.
Intended recipient, does that not have a security implication?
Intended recipient might, although I feel like intended recipient is struggling to find a use case. The last time we talked in detail 2 OpenPGP email summits ago, the people seem to think that intended recipient was potentially duplicative of actually signing the headers. Signing and encrypting the headers, and if it was conflicted, people would lean towards looking at the headers in the email context. Anyway, you're right. You may be right that the intended recipient subpacket does. Anyway,
I think you and Eustace are arguing in opposite directions, because DKG, you're arguing basically that ideally we would only use the imprint and we'd forget about the fingerprint, and I think Eustace is arguing that we only need the fingerprint, and the imprint is unnecessary. Correct me if I'm wrong.
That's right. We're arguing on opposite sides.
Okay, so basically what I'm trying to do here is keep you both happy by putting both into the same subpacket.
That seems like the worst outcome. If you're serious about imprints, just go with the imprints and extend the network side of the protocol specifications to deal with imprints.
Yeah, that's not going to happen quickly, though. That would be my worry, and we're then saying we can only really use this in practice if we also upgrade all the key servers and all the other distribution methods as well to handle arbitrary digest. So it would be nice if we could. I agree. It'd be very nice. I just think that would slow down adoption even more.
Okay.
Aaron, you had your hand up, or did you want to say something? Or
just that we also use fingerprints in revocation key subpackets, that this could also be very close.
Okay, sorry, your environment is very noisy. I couldn't hear what you said there. Could you throw it in the chat and I'll
in the
read
chat
it out?
he wrote, we also use fingerprints in revocation key subpackets, which is true, but we also explicitly deprecated revocation key subpackets in RFC 9580.
Okay. Okay, so we haven't really reached much of a consensus then. There seem to be basically three lines of attack here. One is the fingerprint is sufficient, one is the imprint is sufficient, and one is neither are sufficient. We need both. And I'm not sure how to reconcile those. Eustace?
I mean, you're concerned about only using imprints, but there is only one lookup mechanism that uses fingerprints nowadays, right? That's HKP, and you're in the process of upgrading that. And all the other network protocols use the user IDs in some fashion to find the key's location, and those are not impacted by using imprints. So my argument, I guess, is that if the replacement key uses the same identifier, then you could still find it.
It is possible in principle to update HKP to support imprints, yes. How soon we could get that rolled out is another question. Yeah, it'd be nice. I'm not expecting HKP to be finished and rolled out anytime. It's certainly not going to be done before this is done. So that would be my concern, that implementation of HKP would lag behind this.
So I just wanted to observe this last bullet point you have here about can we deduplicate if the fingerprint field is null. So because the user doesn't know the length of the fingerprint field for any given key, because there might be a new version of a key that has a different fingerprint length that you don't know. In order to parse this packet, we're going to need to include a fingerprint length octet.
Yeah.
If we have both. And the simple form of deduplication would say if the length octet is 0, then assume that the imprint is the fingerprint. Right?
Okay. Yeah. So I have actually separated that out into another bullet point later on. But you're right to bring it up now, because yes, it is possible, to have some mechanism, and this would be a good mechanism to indicate that deduplication is being performed. So basically, the only issue here is that it may make the parser more complex.
Right.
But if we're introducing fingerprint lengths anyway, is it that much more complex? I don't know.
So the reason that I raise this is for folks, if we roll this out today so that there is room for a fingerprint that can be used to look things up in HKP, and 2 years from now, HKP is updated and we say, oh, you can just query for the imprint directly in all HKP servers that we care about, then you could just start issuing zeros there anyway and say, look it up with the imprint. And so that gives us room to move to that thing without blocking the specification on HKP. And if the goal of the fingerprint is do an HKP lookup, then we can say, we could change the text there to have it done that way. Right. So the text would say, include the fingerprint and put the length of the fingerprint here, unless either the fingerprint is the same as the imprint, or you believe that the implementer believes that anybody consuming this won't need to look things up by fingerprint. They can look things up by imprint. Right. And that's not the state of the world today, but 5 years from now, you could use a replacement key mechanism and just tack a 0 in there to say, yeah, I'm pretty sure we're in that new world.
Okay.
So it seems like a route forward that would, not cost us everything, but still let this thing be deployable and usable today.
So I think it's an interesting proposal. I think there are actually two separate things there which would probably need to be indicated differently, because one of them is the fingerprint is definitely the same as the imprint because it is a V6 key and we're using SHA-256. And then the other one is, I'm not going to give you the fingerprint because you can look it up by the imprint and I don't care, or I'm not going to tell you what the fingerprint is. And that's two slightly different things. One is the fingerprint is the same as the imprint, and the other one is the fingerprint doesn't matter anymore.
Fair. You might not want to conflate them in the syntax, and we can talk through what it would take to do that. But it does seem like if you're going to have a dedupe mechanism, you could have something like that as well. And we just need to now. We may not want to design it at the mic line here, at the virtual mic line here.
Sure. Yeah. Well, it would be possible to do something like that. I suppose the question is that complexity worth it? And I suppose that's really what I'm asking the implementers to consider.
So I am preparing a poll here, worded the same way as the previous ones, to should we drop the imprint field?
Right. We might need to make clear that if the answer is no, then there will be follow-on questions of, regarding what we should do instead. Perhaps.
If the answer is, I guess there's follow-on questions either way we cut it, but just to keep the poll question the same way, I'll just have it the same. Should we drop the imprint
should we
field?
drop it entirely?
Yeah.
Question. Okay.
Folks okay with that? Not hearing any objections or seeing anyone in the queue. Oh, it's an exciting race between no and no opinion.
Yes is catching up. Okay, we have 9 responders. Okay, so I think the answer to that is not yet. There's one yes, and I'm presuming that was Eustace. I think everybody else is undecided. So if we assume that we are keeping the imprint for now, then we need to decide.
For the record,
okay,
it was 4 no opinion, and 1 yes.
Apologies. Yes. So I suppose then the next question is, what should we do instead? So maybe we should vote on DKG's proposal, which is that we should have the imprint and the fingerprint should be optional. And then we will go away and work on a wire format for how to make the fingerprint optional and what circumstances would require the fingerprint to be optional. Is that fair, DKG?
I'll let Daniel go ahead.
Yeah.
Yeah, I agree with most of DKG's proposal. Just I would only do the part of like omitting the imprint or the fingerprint if it's the same. Sorry, omitting the fingerprint if it's the same as the imprint.
Mm-hmm.
But I think the part of looking up keys by imprint later might be a bit overly complicated because as I understand it, this imprint you can create it with any hash algorithm, right? So then the HKP server would basically have to either store a hash, store an imprint using every hash algorithm, or go through all the keys it has and see if the imprint matches, which I think is not feasible, probably.
Yeah, so in order to make that tractable, what we could do is we could impose some kind of limit on which hash algorithms should be used. So for example, we wouldn't allow MD5, obviously, we wouldn't allow SHA-1. We could say that we're limiting it to SHA-2, 256, and SHA-3, for example. And then at some, whenever we refresh the crypto refresh again, we could, if we're updating our digest algorithms, we could then say, okay, these digest algorithms are valid for use in this particular scenario. So it might be practical just to say these subpackets must only be present in a signature using this constrained list of known good hash algorithms. And then if that list is short enough, which I suspect it will be at the moment, maybe only 2 or 3, I think I'll need to double check the list of supported hash algorithms, but I think it's only really 2 that are recommended at the moment. So that would be fine for HKP. We just pre-compute them and store them in the database, and that's not really an issue. If it exploded to something like 10, then yeah, that would become unfeasible to implement in HKP. But if it was only 2 or 3, it's probably fine.
Okay, fair enough. That makes sense to me.
So do you want a poll here that says, should fingerprint be optional?
Yes, please.
The poll is underway. All right, we have the 9 awake participants all oh, now we have 10 awake participants. Okay, so this is a much more ambiguous thing. The workgroup does not have consensus on it. There's 3 yes, 4 no, and 4 no opinion.
Out of 11 responders, yeah. So that's really, really split.
Does anybody want to speak up who hasn't spoken up yet about what the some of these trade-offs are? This is probably, I mean, all of this is going to need to go back to the list anyway.
Yeah.
Yeah, I mean, I think my takeaway from this is that people need to think about it some more. I wouldn't say that we don't have consensus on anything here. I think people need to think about it some more. So it's probably the outcome of the discussion.
So Eustace is asking for another poll, which is, should we drop the fingerprint? I can do that. I mean, that's.
Yeah, I think for I think for completeness, yes, we probably should. Like, I suspect we know what the result's going to be, but I think it's only fair. It's only fair if we hold that one as well. Yes.
Okay, poll is underway.
Okay, that's 10, 11 responders. Okay, yeah, there's 1 yes, which presumably is Eustace, and then everybody else is split between no and no opinion.
6 no and 4 no opinion. Thanks.
Yeah. Okay. So I suppose the takeaway from this is we need to go away and think about this some more. So maybe DKG and I could put our heads together and try and come up with some sort of mechanism which would allow the fingerprints to be optional in a nice, consistent, parsable way. So I think we have a fair idea how that could be done. So yeah, I'd be willing to knock something together, and we can bring it back to the list to see what people think.
The advantage of the fingerprints being optional is what precisely?
It means that at some point in the future, if we update HKP to allow lookups by imprint, so say by SHA-256 or SHA-3 digest over an arbitrary key version, we then don't technically need fingerprints for lookup purposes anymore. Daphne?
I mean, and I see that as a good reason, but are we really saving all that much by dropping a fingerprint in that case? The implementer in a world where HKP can look up things by the imprint can just do that and just ignore the fact that there's a fingerprint there. Like, is it so much savings to add the ability to specify this as 0 and leave it out in this case, but not in that case? Why not just include it? And if people want to ignore it, they're free to do so.
So I suppose the argument might be it inflates the signatures, but as SHA-256 digest is really not that big, particularly when we go post-quantum. It's essentially a rounding error. So that would, yeah. I'm not sure it's a strong argument, but Bart is in the queue.
Yeah, I basically agree with Daphne. I just don't think it's very large, and I'm a little cynical about the possibility of looking up by imprint generically, or at least, there's a lot of places where fingerprints happen. So for me, it would just be, why not include the fingerprint of the, key according to the version of the key it is, the certificate version. And then, worst case, okay, even if something hash is ridiculously broken, you can always verify the identity with the imprint, right? But maybe, but maybe the fingerprint, if it's not, even if it's not something that you would trust to ensure, no collisions, it might still be useful for lookup purposes or other things. So I just don't really see a huge advantage to either making it optional or getting rid of it, simply because I think it adds complexity to what implementations will consume, basically, right? I don't know. Like, every degree of freedom should be evaluated on what it buys us, and if this degree of freedom doesn't, like, I would rather drop it or have it all the time than make it optional, because I think this is historically where, I mean, not to say that this is a particular case, but historically OpenPGP has made everything optional, and as a result, it's just the combinatorics are ridiculous. But I think this has a actual use, at least in lookup, if not otherwise. It doesn't have to be secure if the imprint provides that.
So I just wanted to note, as Stephen noted in the chat, that we have 25 minutes to go of a 90-minute talk, and we're on page 7 of 14. So if Andrew wants to get feedback from the group on more points, we should probably let him push ahead.
Yeah. Well, I kind of knew this was going to be the one that the big argument was going to be about. So the rest of them shouldn't take as long as this page. They really shouldn't. So we'll bring this back to the list, and we can come up with a couple of options. Bart, you're still in the queue? Okay. So yeah, we'll come back to the list with a small number of options for how to proceed, and one of which will be to proceed with the draft as it currently stands, which is that the imprint and the fingerprint are both present at all times. So we'll come back to this. So the other kind of suggestion that was brought up, and Eustace brought this up, and I think it's quite an interesting one, which is that we may wish to tell our correspondents to encrypt both the replacement key and the original key. So let's say, for example, we have a desktop machine and we have a phone, and the phone doesn't support post-quantum yet. So we might want people to encrypt to both. Now, you might argue that, well, you're losing all the advantages of post-quantum if you say people have to encrypt everything to your non-post-quantum key anyway. But there may be other scenarios where this is where this is desirable. So this opens, in my opinion, this opens a bit of a can of worms, because we've already had issues like this in OpenPGP previously with how do we deal with multiple encryption subkeys on the same key. So some implementations will encrypt just to the latest one. Some implementations might encrypt all of them. So there isn't a really hard consensus about what to do, and it isn't specified in the RFCs what people should do when they see multiple encryption subkeys on a key. So in my opinion, anything that we decide policy-wise around how to treat encryption subkeys of equivalent keys, it should follow the principle of least surprise. It should be as close as possible to the behavior that we want to specify for multiple encryption keys on the same key, just to keep everything nice and even. The problem is that we have no consensus on what to do in that scenario either. Now, there have been a couple of proposals already for how to deal with things like this. So commercial PGP, which is Broadcom PGP, PGP Corp, whatever it's called these days, supports the additional decryption key subpacket. This is subpacket ID 10. GNU-PG GNU-PG supports it to the extent that it warns about it and throws it away. GNU-PG calls it the additional recipient request. If you look in the RFCs, subpacket 10 is marked as a placeholder for backwards compatibility. Basically, PGP Corp experimented with this in the late 90s. But when they implemented it, they didn't require it to be in the hashed area, and there were bug reports about it, and everybody ran away screaming. So it was never included, as far as I can tell, in any of the RFCs. And I think Werner mentions that somewhere on one of his recent blog posts as well. GNU-PG has now implemented the additional decryption subkey, which is essentially a similar mechanism, but it uses a subkey rather than a full key. But the specification, again, is a little bit thin. It's not clear how that interacts with encryption subkeys. From the mailing lists, it seems that it's intended to be that you should encrypt to this key in addition to the one encryption key that you have decided is the most recent usable encryption key. So it's a little bit of a halfway house between encrypt to only the most recent and encrypt to all. So there are a few ways that we could do this. So we could use a flag bit in the class byte to say that this particular fallback key also acts as an additional recipient, but that would have to be in the that would have to be put into the fallback keys signature, because there's only one class octet per subpacket, and if you put that into the replacement keys inverse direction, it's not clear which particular fallback key it's referring to. So that gets really messy. There's multiple lookups and multiple indirections if we want to do it like that. We could just go and disinter and resurrect subpacket type 10 and maybe bump a flag byte in it to make sure it can't be confused with the PGP Corp version. Or we could define a new subpacket which has the similar semantics to keep things nice and clean. Or we could just take the path of least resistance and just duplicate all of the encryption subkeys on the replacement key. And then just tell everybody that they need to encrypt to all encryption subkeys. But that would require us to make a decision that a correspondent should encrypt to all usable encryption subkeys rather than just the most recent one. So this, like I say, I think this is a can of worms. I'm not sure dealing with it in this draft is productive. Maybe we need to go back and think about it and come back with a recommendation later, or some kind of consensus at a later date about how to deal with multiple encryption subkeys, either on the same key or across equivalent keys. But I think it's a big issue and might be too big to tackle right now. So I don't know, does anybody have any opinions? Eustace, do you have anything in particular to add to this? Have I interpreted your intent correctly?
Well, you said just add the encryption subkey to all of your certificates. That doesn't quite work. My motivating example was actually that my phone doesn't have a v6 implementation yet. But my desktop has. But I can't stick the either the v4 encryption subkey to my v6 key or my v6 encryption subkey to my v4 key. So that workaround doesn't seem to work.
Yes, because if they're v4 subkeys and v6 primary keys, we've forbidden that. Yes. So yes, you're right. Yes, you are right. So the fault, just duplicating all of the encryption subkeys doesn't work. You're correct. So in that case, do we need to resurrect the additional decryption key mechanism?
Is there? Oh, Daniel, go ahead.
Yeah, sorry. I was gonna say I kind of am tempted to say the mean thing, which is like if you don't support v6 on all your devices yet, or you don't have a v6 implementation on all devices that you use, maybe you should say that you shouldn't generate v6 key yet, right? Because otherwise, because if you do, you also don't get the benefit. Like if we ask all senders to encrypt to both keys, then I mean you don't get a security benefit from the new key yet, right? So I'm not sure then what's the benefit of even generating one.
Yeah, I thought we are talking about providing a smooth upgrade path for users. And that doesn't necessarily mean I want a security benefit right now.
Well, you might want a security benefit if the recipient also supports it, right? I think that the smooth upgrade part is about saying I support v6, but I don't know if the sender supported yet, so I also provide a v4 key just in case the sender doesn't support it. But if they do support it, then we can use v6 and also PQC, for example, and then we get the security benefit in that case, right? But if you don't support v6 yourself yet on all your devices and you're asking to always encrypt with both, then you never get a security benefit, right?
Well, I mean, I can evolve my preference over time.
Okay.
So Poe has been in the queue for a while here.
Sorry.
Yeah. Question to Daniel: how do I know, as a normal user, how do I know that my phone doesn't support v6 yet? Like in Proton closed ecosystem yet, but if I have Thunderbird and K9 mail,
Yeah, I think there are questions about the user experience, definitely. Like this would be something for advanced users. It's not something that I would expect the kind of average casual PGP user to be interested in. So yeah.
Yeah, so point being, I think, like, as an advanced user, I know that my phone doesn't yet support v4, so I can hold back and not yet generate a v6 key. But my Thunderbird may not know that I have a phone, because maybe I set up my Thunderbird first and later I want to add my phone, and now I'm in a situation that user said.
Yeah. I don't have easy answers off the top of my head. I think this is a huge subject. It's a scenario that I think surprisingly we didn't cover much in the last email summit. We were mostly concerned about correspondence, not supporting the same version as each other, but the multi-device scenario is one that I think we do need to think about some more. I don't know, has anybody else got any input or suggestions? We can, of course, take this back to the list. We can go away and think about this. We don't need to deal about it. I don't think we're going to get an answer to this today.
I don't even see how to frame a poll for it, given the range of possible pieces. But if someone wants to propose a poll, I'm happy to run one. We also have about 10 minutes left.
Yeah, the rest of the slides should be fairly quick. I don't think we have a concrete proposal that we can say yes or no to right now. We have an open-ended question currently. I don't know if there. I think we need to spend more time thinking about this on the list before we come to the point of view of polls. I don't know if anybody else disagrees, but I think this is still too fuzzy to poll people on. Okay, I don't hear any objections, so I'm going to move on. Yeah, the other thing that we do need to think about, which we haven't really touched on in the draft yet, and again, this is going to be an open-ended question, so I don't expect there to be a poll after this, but it's something that we do need to bring, to go away and think about. How do we expect users to create the bidirectional signatures on the original key and the replacement key? So do we need them to both be online at the same time? So does the user have to have the private key material of both the original and the replacement in order to make these signatures? Because if we do, then it's easy. It's a single operation. Create a replacement key signature on both with the trust binding, and it's all done. But that's quite restrictive, because if you may have them on different removable devices, different YubiKeys, keys, whatever. So another way we could do it is we could go to the replacement key, and when we create the replacement key, we prompt people and say, is this a replacement for something else? If yes, please specify XYZ. And then we can go back, and maybe on a different device, we can go to the original key. We can pull updates, and it will see, oh, this other key claims to be a replacement for the one here. Do you confirm yes or no? And then it can create the matching forward replacement key subpacket. But we need to support multiple ways of doing this. You'd need to support, doing the old one first and then the new one afterwards, and vice versa, so as not to restrict people too much. But it is going to involve a little bit of juggling of secret key material when people do create these. So we do really need to think about what kind of experience we want them to have when they are creating these new objects. So I don't think this is worth a poll. I think, again, this is too open-ended and fuzzy, but it's something that I believe we should take to the list. Unless I have missed something, in which case, please speak up. Okay, no takers, so I will power on. Sorry, Daniel.
Sorry, I just wanted to mention, I put it in the chat, but if you're an implementer and you're thinking about this, please think about how you would update SOP to create these bindings, because if we want to test interoperability, we'd like to have it in the interop test suite, which uses SOP. But more importantly, think about how you might want to use SOP to evaluate these bindings. I have some ideas about how we could update the stateless interface to create them in the sort of more flexible way that Andrew's outlining here. I'm not sure that's the right choice, but I actually have no idea how we would use SOP to test whether keys are equivalent, other than like a whole separate subcommand or something like that. And I don't know whether that's something people want to consider, or, but I'm looking for suggestions on that so that we can actually test the interoperability between implementations.
Okay, thanks. Anything else for this page, or will I wrap up? Okay, I will wrap up. So there's just a couple of other things that are open. I don't want to go into too much detail here because I think they're relatively straightforward. I just want to inform people that they're there. We do need to put fingerprint length fields in anyway. So as Daniel DKG was mentioning previously, we could use fingerprint length fields to say whether fingerprints were present or not. Because this is a generic mechanism, we can't assume that everybody knows the length of every possible fingerprint version that might appear in one of these subpackets. So we do need a fingerprint length field to simplify the parsing of the list. So it's not important in the case where there is only one target, because the fingerprint is just the rest of the subpacket. But when there are multiple targets in a list, you need to be able to iterate down through them, which means you need to know their lengths. So we do need a fingerprint length field. That's relatively straightforward to put in, and I'll do that before the next draft version. And then there have been just a few things have been brought up by a couple of people about various language improvements, and that is, of course, ongoing. This is the slide that I threw in for a laugh. We need the bike sharing. Is the name currently too long? I keep calling it replacement key mechanism in all of these slides and presentations. It's actually replacement key signaling mechanism currently. I'd maybe like to shorten it to replacement key mechanism officially. The other thing is, do we call things a class octet or a flags octet? The flags octet is more descriptive of what it is, but class octet is actually used in more places in the RFC. So it's a tiny inconsequential thing, but I think OpenPGP in general is inconsistent with its terminology, so I don't want to make that worse. But again, we don't need to get into that here. So the links are here. I think they're in the chat as well. I think DKG's already put them in. So discussion, I think, will continue on the list or in the issue tracker. I will be making a couple of changes, just as mentioned on slide 12 there, just about the fingerprints. But otherwise, that is me. Thanks very much. Stephen.
Yeah, just a question. I have no opinion on the answer. Do we have a kind of a view of a timeline for when we think this might be doable, done? Do people have sort of this year, next year kind of goals for this?
I would like to be able to get this into reasonable shape this year. I suppose the question is, are we going to expand the scope of this anymore? I personally hope not, but people may think that we do need to deal with the multiple encryption subkeys issue. If they do, that might push it back, because I can see that's going to be a huge discussion. But if we can punt that decision to some other draft or some other venue, then I think this is doable in a few months. Yeah.
Great. I mean, I think it's useful for people to have some kind of timeline in their heads as they react to it and think about things. Cool. Thanks for leading us through that. DKG, did you have any kind of wrap up kind of things to do, or?
Nope, not from me. I will try to send a follow-up mail to the list once we have the notes covered. And Andrew, of course, please keep the working group apprised of your progress. Obviously, people who you get a chance to sleep on this, you want to follow up on list of things, something you realized but didn't have a chance to say here. We welcome the feedback on the list too.
And I guess the only other thing is I'm assuming we should probably ask for a session in Dublin, and this will be on the agenda.
I think that's right.
So, yeah. And I hope to make it physically this time, considering that Dublin is just down the road. So I'll get to meet Stephen finally.
Good stuff. Okay, any other last words from anybody, or are we declaring victory? And thanks to Daniel for taking notes.
Yes, thanks everybody.
Sounds good. Thanks, y'all. See you on the internet, and let us know if you have questions. Post to the list.
Thanks all. Bye-bye.